Hi everyone, this is part 2 for the video on related rates for Math 1451 at Texas Tech University, which is Calculus 1. So in the first video, we talked through the 6 steps to solve a word problem. And in this video, we're going to apply these strategies to solving a word problem on related rates. So this example says, to consider a cone with a radius of 6 inches, we are wanting to find the rate of change of the volume if the radius is increasing at a rate of 2 inches per minute and the height is 3 times the radius. So our first step in solving this word problem is to identify our known and unknown quantities. So what I've done is I've just pulled out all the phrases of the word problem to see what they can tell us and how we can translate these words into math. So first off, we are considering a cone with a radius of 6 inches. Okay, so this tells me that the radius equals 6. Next, we are asked to find the rate of change of the volume. So this is going to tell us that dV dt is our unknown, because we're asked to find the rate of change of the volume. So we know that the volume is changing, so that V is on top. And we know that all of our rates are respect to time, so we know it's dV over dt. Next, we know that the radius is increasing at a rate of 2 inches per minute. So that means that dr over dt equals positive 2 because this radius is increasing. And lastly, the height is 3 times the radius. So this tells us that h equals 3r. But we know that our radius is 6 from that first line. So this tells us that our height is 18. Okay, so these are the variables that we can pull out from the words in the question. So next, we are to find a formula that includes all of the quantities in our question. So this question has already kind of told us what our formula is going to be, because we're looking at a cone and we're specifically trying to find the rate of change of the volume. So that tells us we're going to use the volume of a cone formula. So the volume of a cone formula is going to be 1/3 pi r squared h. So this formula is really similar to the volume of a cylinder. It just has a factor of 1/3 in front. So if you need a refresher on these volume formulas, you may ask your instructor which volume and area formulas you'll need to have memorized. So for example, do you need to memorize the formula for a volume of a cone, or will that be provided to you? So that's going to depend on your instructor. So we have this volume of a cone formula, and now step 3, we apply implicit differentiation. So we're going to take the derivative with respect to time on both sides of my equation. So my left side is going to become dV dt. And what I'm going to do on my right side is I know that I can pull scalar multiples out of a derivative. So that's exactly what I'm going to do, and I'm going to factor out this 1/3 pi. And I'm going to now take the derivative of r squared h. So because I'm taking the derivative of r squared h, and r and h are different variables, that's going to tell me that I'm going to need to use the product rule to take this derivative. So this is going to be 1/3 pi. And then my derivative of my first is going to be 2r dr dt. My derivative of my first times my second, plus my derivative of my second is dh dt. And I'm going to multiply that times my first, which is r squared. So you can simplify this how you like, and I'm going to simplify it here in number 4. So I'm going to simplify this as dV dt equals, and I'm going to distribute this 1/3 pi to both terms. So I'm going to have 2 pi over 3 RH dr dt plus pi over 3 r squared dH dt. Okay, so I'm going to have this, and next I'm going to plug in all of the known quantities that we had from step 1. So whenever I plug this in, I'm going to have, we don't have anything to plug in for dV dt, so I'm just going to leave it like it is. So we're going to have 2 pi over 3 times our radius of 6 times our height of 18 times dr dt, which is 2, plus pi over 3 times our r squared times, we don't have anything to plug in for dH dt. Okay, so this is what I have. And so we can simplify this just a bit. So this is going to equal 144 pi plus 12 pi dH dt. So this just came from simplifying all those numbers. Okay, so now we need to solve for our unknown quantity, which is dV dt. So if everything went correctly at this step, we should have one equation with one unknown that we're solving for to solve for our unknown quantity. However, we can see here that we didn't have anything to plug in for dH dt. So what happened? So you may get here and say, I wasn't given all the information in the question. I wasn't told anything about DHGT, so what do I do? So in this case, we actually need to do some problem solving to figure out what we can plug in for DHGT. So specifically, when the formula that we're using in a related rates question has more than 2 variables, there's going to be some relationship between the variables to make sure that we only have one unknown to solve for. So in this example, we're going to need to find some relationship between the height and the radius, which were the 2 variables in my volume formula. We have radius and height. We need to find some relationship between these 2 variables to figure out what dH dt is equal to. So in particular, we can look back at this last clause from our identification of known and unknowns. And we can see that, oh, okay, I have that my height is 3 times my radius. So that is going to tell me something. So if we come down here and we can keep going. So I know that my height is 3 times my radius. So just like with our volume formula, we have an equation here, and we can apply implicit differentiation to both sides of this equation. So whenever we apply implicit differentiation, we can see that dH dt is 3 times dr dt. So what this tells us, if the height was 3 times the radius, the rate of change of height is 3 times the rate of change of the radius. So again, we know that dr dt is 2, so we can go ahead and plug this in to be 6. And now we can finally say that dV dt equals 144 pi plus 12 pi times dH dt, which was 6. So this is going to be 144 pi plus 72 pi, which is 216 pi. Okay, so we were able to solve for our unknown quantity. So remember that our last step is to write our conclusion. So that means that we solved for dV dt, and that represents the rate of change of the volume. And we found out that this was positive 216. So again, I just want to pause here and say, does that make sense? So we can see that the radius was increasing whenever we were filling a cone. So it makes sense that if the radius was increasing, so would the volume and so would the height. So the rate of change of the volume is 216 pi. And now we need to think about okay, what is our unit here? So because we're dealing with volume, that means we're going to have cubic units. If we were dealing with area, we would have square units. And if we had length, width, height, radius, anything like that, those are just going to be normal units. So the radius was increasing at a rate of 2 inches per minute, which tells us our volume. So radius was increasing at a rate of 2 inches per minute, which tells us that our volume is increasing at a rate with cubic inches per minute. So this is our conclusion. We have written a full sentence that tells what's happening in this problem with correct units. So we're going to stop here for this video. If you want to see example 2 worked out, you can see that on the filled version of this worksheet, where you can see example 2 worked out. It works very similar to this one, where you have to work a little bit harder to figure out the relationship between the radius and the height. But we hope that this helps you understand related rates a little bit better, and good luck.